Welcome! I will be your host for today. My name is Rosamir Isidoro, and we will talking about one of the many examples of the application of physics in our daily life. But did you know some of the phenomena or events around you are one of the example of physics? Let's say for example the ship. How do you think it stays afloat in the water, traveling far distances without sinking? That can actually be explained by some of the concepts in physics, like density, buoyancy, and many more. This and some other phenomena around you are one of the many examples of the wonders in physics which make it quite unique than the rest of the other sciences. I personally love physics. Physics is everywhere. When we sit, there is physics. When we talk, there is physics. When we hear sound, there is physics. So physics is actually understanding of nature. If we check the root word of physics, physics actually was derived from the Greek word physis, meaning nature. Physics can also be defined as the department of knowledge, which relates to the order of nature, or in other words, to the regular succession of events. Physics is like an understanding of your experience, or even the experience of those around you. You can understand physics by learning the basics and applying it on what you experience or see. So, there are no complications like you have to memorize from page 1 up to the last page of the book just to understand physics. No, it's not that. Just knowing the gist of the concept actually enough of helping learning physics. So, for tonight's topic, we are going to focus on the discussion why there are some areas that gives bad mobile signal or phone coverage. A lot of you have experienced this when you have your vacations, say in the mountains, while traveling, or even your respective workplace. There are times that it's hard for you to make a call, so you have to step out of your office just to get a good signal. So before we discuss the factors affecting the mobile signal, let us first discuss the telephone, the ancestor of the wireless cell phone. So here are some of the important contributors as to why we have our cell phone today. First is in 1874, Alexander Graham Bell discovered the concept of the telephone, which in some way the ancestor of our wireless cellular phone. In 1876, Bell invented the first telephone, and in 1972 to 1973, Martin Cooper along with his team invented the wireless cellular phone and made the first wireless cellular call, making him the father of the cellular phone. So that is how the telecommunicating industry evolved. So now, let us discuss the factors affecting mobile signal. So there are many contributing factors affecting the deterioration of mobile signal. The result of the areas with slow to no mobile signals are what we call the black spots. The black spot is generally defined as a geographic area or a particular spot in your area that experiences reduced mobile phone signal due to factors other than being too far from a cell tower. Black spots have similar impact as being too far from a cell tower and are typically linked with symptoms like number 1, call drop out. So this happens when your call gets disconnected somehow in the middle of the phone conversation from the cellular network. Number 2, digital garbling or robotic noise. during a call. We usually say, choppy ka. Difficulty hearing the other caller. Number 4, network timeouts or no signal issue. And number 5, increased battery usage, since if your phone has a weak signal, it's hard to work harder to keep you connected. Thus, increase in the consumption of the cell phone battery. There are some of the common symptoms that we experience caused by the factor which affects our signal. Number 1, cause of the mobile signal black spot is due to the area of terrain between the cell tower that is sending out the signal and the mobile device that is receiving it. Being part of the electromagnetic spectrum, both radio waves and light waves act the same way when it comes to obstructions, so it can be easier to understand the science behind mobile telecommunication. Signaling by visualizing it in the same way. A mobile device receives signals by connecting with a nearby cell tower via radio waves. The behavior of these waves as they travel to a mobile device is the same as that of the light waves, much as shadow that is cast by light hitting an object. When there is a significant variations in the terrain that block the path between a cell tower and a device, much of the signal is unable to pass through and reach it directly. The closer an object is to a surface, the darker its shadow becomes. The farther you move the object away from the surface, the lighter the shadow becomes. The cause of this is known as diffraction, where there is sudden obstruction causes electromagnetic waves to bend inwards to the shadowed region. This process causes the areas of strength and weakness in a device connectivity. Number 2 factor is non-terrain obstructions. Non-terrain obstructions work in a similar way to natural obstructions. However, it is dependent on the material that stands between the cell tower and the connecting device, because the effect that an object has on a signal strength depends on the material's ability to penetrate. Objects along the path of the radio transmission are a big contributor to a channel fading. Physical obstructions, namely buildings and trees, that are typical culprits. Not only that, there are other objects that cannot be penetrated by the radio waves, but instead, they reflect them back, causing various other signals path known as multi-path environment. Number 3 factor is antenna or angle or tilt. In some instances, you may not be far from the cell tower and free from any obstructions, and you still suffer from a poor signals. This can be due to the angling of the broadcasting antenna on the cell tower. Although in most densely populated areas, telecommunication service providers use 3-directional broadcasting antennas with each focus to cover a sector of 120 degrees. Some more basic towers have one transmission antenna which can cover full the 360-degree radius. Although the latter may sound good, but each transmitter has a capacity limit. So by only using one, it means you are limiting the number of users and speed that is available. Number 4 factor is building penetration. Experiencing poor reception despite ample coverage outside the house or office is a clear indication that the building itself may be the culprit. Dense or metal-based building materials can reflect or absorb radio waves, reducing the level of signal that reaches indoors. Some of the examples of these materials are foil-based roof insulation. Because cell phone signals are electronic, the aluminum foil prevents the signal from reaching the cell phone. Next is the concrete and cement, or 6 inches thick, reduce the ability of the radio waves to penetrate the object. Next is the solid wood. Any type of wood from beech ash, oak, mahogany, or maple very capable of absorbing and blocking signals. The thicker the wood, the worse the signal. And the last one is the metal. People with metal roofs find it difficult to get reception. Even having metal inside the home creates distortion of radio waves. So these things that I've mentioned a while ago are some of the factors affecting the strength of our cell phone signals. So the reason why when you go hiking, you have weak signal or even you don't have signal or making it hard for your family to contact you, or even you are in the city, you may still experience signal interruption possibly because of the obstructions around you, or even how dense the population in your area is using the same network provider. That is why Globe during events like Mascara gives you a hard time to send messages or call because you are in the same area. So how far you are located from the antenna of your network provider. The reason why Globe has a weak signal in Himamaylan compared to Kabangkalan, and when you are using Smart, the signal is good in both Himamaylan and Kabangkalan. So this is the end of my presentation. So thank you for watching, and thank you for watching Physics in Our Everyday Life again. This is Rosamir Isidoro, your host for today. Thank you.